So the other time I talked about your cable sizing when you are installing your submersible pump, right? This is very, very important because a lot of pumps, submersible pumps especially, are underperforming or having, electrical or even mechanical issues because of undersizing of cables, right? We understand the difference between cable and wire. A wire is a single conductor, right? While cables are multiple wires interwoven as one. So in pump installation, we use cable. We don't really use wire. So now these cables come in different sizes, as we all know. So cables are measured, you know, in a millimeter square usually, not millimeter, not mm. So sometimes you see our people, telling you that I'm using 1.5 mm. No, millimeter is a measure of length, but while millimeter square is a measure of area, cross-sectional area. So you must always remember that wires are measured in cross-sectional areas. So it must be in millimeter square, or cm square as the case may be, depending on the size. But usually is millimeter square. Now, there's a relationship between resistivity and length of wire and cross-sectional area, which is given as rho. Rho is resistivity equal to the product of resistance and cross-sectional area per length of the wire. For instance, it means that, graphically or mathematically stated, that rho is equal to RA over L, where L is the length of the wire, R is the resistance on the wire, and A is the cross-sectional area of the wire, while rho is resistivity. Now, if you look at this properly, by the time you do a bit of mathematics, you're going to see that rho L is equal to RA, which means the product of resistivity and length is equivalent to product of resistance and cross-sectional area. And what does that mean? It means that the length of the wire is actually directly proportional or has a relationship with the cross-sectional area. And then the length of the wire in this case is determined by the depth of the borehole and your determined depth of installation. I can drill a borehole of say 100 meters and I decide to install at 90 meters. That means that the length of my wire will not be 100 meters but 90 meters. And I'll just use that as an example. So in this chart, I've tried to do a few compilations where you see for a single phase motor, particularly, let's say the common pumps we use for single phase is 1 horsepower or 1.5 horsepower, which is 1.1 kilowatt or 0.75 kilowatt. Now, for a length of 0 to 15 meters for 1.5 horsepower pump, you use 1 millimeter square if the length is not exceeding 15 meters. Now, if the length is between 16 meters to 30 meters, you use 1.25 millimeter square. If it's between 31 to 41 meters, you use 1.5 millimeter square. And of course, if it is from 31 to 60 meters, you use 1.5 millimeter square. And from 61 to 75 meters, you use 2.0 millimeter square, which is the same thing with, between 76 to 90. So basically, in summary, if the pump, 1.5 horsepower, for instance, you're using it, it should be between 0 to 15 meters. You use a cable area, cross-sectional area of 1.0 millimeter square. For 16, from 16 meters to 30 meters, 1.25 millimeter square. From 31 meters to 60 meters, you use 1.5 millimeter square. And from 61 meters to 90 meters, you use 2 millimeter square. You could see that it would be wrong for you to drill a borehole of 90 meters or drill a borehole of 100 meters and you want to install at 90 meters. Then you go ahead and start using 1.5 millimeter cable. You're actually undersizing and that pump will not perform. Sometimes you will know what happens. The relationship between temperature and resistance and all of that. So sometimes because you have undersized, all right, what happens? You see that sometimes the wire is heating up, and when the system heats up, that's what happens sometimes when the wire starts burning and all of that. So this is just the summary of what you should do when you are selecting your cable for pump installation. But most importantly, this is just a guide. Every pump has its own specifications in terms of cable sizing and in terms of temperature of operation and most of other things. So for each pump, you must have handy. Most times if you buy a new pump, you're going to see, not most time, all the time, you should have a pump. The pump should have the operational manual. You can see that here. So you should look at the operational manual and read through and see all of these details, because this is very, very important anytime you're installing your pump. All right, this is what you must do. It is the same way with when you want to, if somebody asks you now, I bought some materials, I have wire. You ask the person what's the size of the wire. He tells you I have, say, 2 millimeter squared, or I have 1.5 millimeter squared, and I want to install 2 horsepower pump. Simply tell him that it won't work. For instance, if you go to 2 horsepower pumps, or let's say 3 horsepower pump, now you're going to have that. When it's between 76 to 90 meters, you'll be using 4 millimeter squared. And today, when we tell some of our professionals that you can actually use 4 millimeter square to install a 3 horsepower pump, they will tell you it's too big, it's too big, it's too big, without considering that the depth is already above 75 millimeter, right? Imagine if you do a borehole of 120 meters and you want to install at 100 meters, and you want to use 2 horsepower pump, you go ahead and start using 1.5 mm squared. And when you use 1.5 mm squared, the pump certainly will underperform. It's as simple as that. Either the flow rate doesn't align with the specification, or the customer is complaining that he's not getting value for the product you supplied or you gave to him. So this is very critical anytime we are considering pump installation. And I'm glad that I'll be at your service anytime when, if you have any need concerning pumps installations, pump failure and maintenance. All right, we are your shop plug. You can always reach out to us. We'll try to get a good design for you, give you, recommendations and all that, and you'll be happy for it.